This video is an applied example on using marginal cost to determine the cost function. So just as a quick definition here, marginal cost is the derivative of the cost function. So if given c prime of x, which we just said above is the marginal cost, we can then find the cost function c of x by integration, or by taking the antiderivative. So, if they give you marginal cost, right, marginal cost is the derivative of the cost function. So the antiderivative of that would just be the cost function. That's why we're saying we can find c of x by integration. And then just as a note, right, it's similar for, if I say r prime of x, meaning the marginal revenue function, and p prime of x, the marginal profit. So let's take a look at an example that uses this. So in this example, we'll say a company determines marginal cost to produce the xth unit of a product to be, and they give you a function. So to be c prime of x equals x cubed minus x. Find the total cost function, which we'll call c of x, assuming c of x is in dollars and fixed costs are $6,500. So they're giving you the marginal cost, right? So it says a company determines the marginal cost to produce the x unit of a product to be c prime of x equals x cubed minus x. They want us to find the total cost function, which is called c of x, assuming c of x is in dollars and fixed costs are $6,500. So first off, some things to point out, right? X is the number of units, right? C of x is in dollars, so the units on c prime are dollars per unit. The units on C are going to be just in dollars. When they say fixed costs are $6,500, they're giving you information here and you have to use it later in the problem. What they're really telling you is that the cost, when you produce 0 items, right, the cost as a fixed cost, right, is equal to 6,500. So it's telling you when x equals 0, right, the c of x is $6,500. So this is an initial condition they're giving you. They're saying c of 0 equals 6,500. We're going to use that later to get our particular solution. So when I go to write my solution for this, the first thing to keep in mind is that I'm looking for c of x, right? I'm looking for the cost function. The way you're going to find it is they told you the derivative of it. So if you take the antiderivative, the integral, right, of c prime of x with respect to x, that will give you the original cost function. And you know what c prime is because they told you. So we'll substitute in here. This is going to be the integral of c prime of x is x to the third minus x dx with respect to x. And then we want to take the antiderivative. Now, The antiderivative here, you don't need to rewrite any of this function, but if you did, make sure you would. But in this case, we already have what we need. The antiderivative of x to the third, remember how it works. You're adding 1 to that exponent, so it'll be x to the fourth power, and you divide by the same new exponent. So you divide by 4. So you add 1, divide by that same new exponent for x to a power. Minus the antiderivative of x, well, the same rule, that's really x to the 1. So the antiderivative of 1 plus 1 in the exponent makes it x to the 2, and you divide by 2, and then make sure you put plus c at the end. So, there's nothing really to simplify here. This is actually going to be the general solution, right? So our general solution, all right, so the general solution would be c of x equals x to the fourth over 4 minus x squared over 2 plus c. Now this is just the general solution. I didn't actually answer the whole question because they said assuming c of x is in dollars and the fixed costs are $6,500, that's giving you information on how to find c. So you use this initial condition, right? So you use the initial condition. All right, so use the initial condition c of 0 equals 6,500 to find our constant c. Well, what's that mean? You're subbing in x is 0, the y value is 6,500, or c of 0 is 6,500. So if I'm writing this, c of 0, it's equal to, subbing in for x, right? Everywhere you saw an x, you're putting in 0 now. You have 0 to the fourth over 4 minus 0 squared over 2 plus c. And we know this should be equal to, this is what it's telling us, equal to 6,500. So we say this equals 6,500. And in this example, it's pretty easy because the terms with 0 are going to cancel out, right? 0 to the fourth is 0, divided by 4 is still 0, minus same thing here. So minus 0 is 0. So I end up with c equals 6,500. Now remember, c equals 6,500 isn't your answer. Your answer for the particular solution is, so we're going to take c here and we're going to sub in 6,500. So our particular solution is c of x equals x to the fourth over 4 minus x squared over 2 plus 6,500. And then that would be your cost function, given that initial condition, right? If they told you fixed costs were a different amount, then you would have a different value for C. They also could have told you, the cost to sell so many items at, like let's say it said the cost to sell 2 items was a different number. Then you could use that in here, and you would just have to solve that for C that way. So this is the particular solution, right? And this is the one that we really want in this case, right? The particular solution is when they give you an initial condition, it helps you find what C is. You could use this function now that we have it for any number of items X to figure out the cost to produce that many. All right, so hopefully this example helps.